السلام عليكم ورحمة الله وبركاته. أسعد الله صباحكم جميعا. اليوم إن شاء الله مكملين معاكم chapter 16 بنحل آخر سؤال في هذا السكشن. So in this problem 16.8.2 at the instance shown the rod AB, this is AB, has an angular velocity omega AB, so omega AB is given, and an angular acceleration, here is the angular acceleration. Determine the angular velocity and angular acceleration of the rod CD. So we need to find the angular motion of link CD. So let me activate the pen. So if this one rotates like this, we'll expect that this one will rotate in this direction. Okay, so this is in terms of W or in terms of omega. Alpha. And you know very well that the slider or the collar is sliding on link AB and being connected to CD. So the Coriolis effect will appear on this link. So if we'll apply the equation, so this equation will be valid only for the link AB. Okay. Okay. Let's now move to the solving board and try to solve this problem. So in this problem, everything is given for the rod where the Coriolis effect appears. So we are talking about rod A, B, but I will not write the whole rod. I will not draw the whole rod. I will draw only from A to C. Okay. And there is very important notice I mentioned last time that the selection of the coordinate system must be done before starting. So usually we select the primary and the secondary coordinate system to be coincident on each other. So and they are flow with the rod. So we must pick the coordinate system which will start from fixed point. So this is X capital. And here is Y capital. And also we'll select the other coordinate system, Y small, X small. Okay, so they are flowing with the link where the Coriolis effect occurs. Okay. So going back to this problem, so from A to C, it's given that its distance is equal to 0.75 meter, and the coordinate system, as we mentioned, let me change the color. Here is the X, and here is the Y. Okay. And another thing is given for this problem is the angular motion, so omega AB or omega in general for this rod 4. Wait a second. And also alpha is given to the two right versus square. Okay, this is everything. So let's now go to the velocity equation. You know what? I will finish from velocity equation for both lengths. Okay, for both lengths, and then we'll move to the acceleration equation. So the velocity equation for this length is equal to Vc, and this is equal Va plus omega cross product Rc with respect to A plus Vc with respect to A. Now, regarding the directions, we know very well, let me go back to the slide. We know very well that the point C has velocity direction perpendicular to the link DC. دائما شباب بنعين اتجاه السرعة C من اللينك أو من من اللينك اللي بتكون السلايدر بين كونكتد معه. So هذا اللينك DC بين كونكتد مع سلايدر C. So السرعة راح أختارها to be. So إذا هذا بلف زي هيك معناته هذه النقطة راح تتحرك كالآتي. اوكي اتفقنا عليها. So دائما النقطة اللي بتكون بين تو لينكس أو سلايدر اختار النقطة اللي بتكون بين كونكتد بين سلايدر والرود، بالتالي بحدد اتجاه الفيلوسيتي. So I will expect that this velocity with respect to this coordinate system إذا بدي أنقله لحديت هون عشان أتخيل كيف حيكون كم مركب حتظهر معاي. So نختار coordinate system ثاني. So هاي ال y اوكي وهاي ال x. So وأنا بحل لازم يظهر معاي مركبتين للبي سي، مركبة في الواي بي سي واي بوزيتيف، ومركبة ثانية في الإكس بي سي إكس. okay. So هذه my expectation. طيب خلينا نرجع لل solving board. So I will leave it as is. I will not write anything for BC. I suppose that you will not be able to find it. Velocity for point A is equal to 0 because this is fixed point. This is equal. So omega for this link is given and it is counterclockwise. So we'll assume that the counterclockwise is positive. So I will substitute for K cross product. Now we'll move from A to C. We'll move in positive X and a distance of 0.75. So 0.75 in positive I direction for the inclined coordinate system. Plus, now I'll move from A to C. I will assume this quantity is a positive equal and it is in I direction. Okay, so cross product, K cross product I, and it is multiplied by 0.75. So we are talking about 3 and it is positive. So 3 in the J direction. Okay, plus BC with respect to A in the I direction. Okay, so yeah, here we have two components, but still we do not know the sign of BCA. As we expect, it should be negative. So let us name this equation as equation 1. And let us finish first from velocity. So I will move to the new rod. So I will move to rod DC. So here is the other link. This is D, and here we have C. Okay, and remember that this is the point A, and on this point the coordinate system is inclined like this. Here's X, and here we have Y. Now this link DC is been connected with the slider. Okay, so we'll use equation from 16.7, and this length is 0.5 meter. Okay, and this length make an angle of 60. Okay. So here, what should we say? We should say VC is equal to BD plus omega CD cross product R C with respect to. So this velocity is equal to 0, and we assume that this length or this link is rotating clockwise, so minus omega CD k direction cross product. Now here is the question. If we want to move from D to C, then we'll not move in X or Y. We'll not move only on X or in Y. We'll move in both direction. Why? Because we'll follow our coordinate system, okay, which is this one. Okay. So first, I will extend the X coordinate system. So if I want to move from D to C, first I must go in the negative Y axis. Then I need to move in the positive X axis. Okay, and this angle, let me change the color. This angle is 60. So we are talking about this angle, which is 30. Okay, now I will name this one Y and this length is X. So sine 30 is equal to Y over 0.5. So Y is equal to 0.5 sine 30. Okay, and X is equal to 0.5 sine 30. So cosine 30 multiplied by 0.5 is equal to 0.433, and 0.5 sine 30 is equal to 0.2 meter, of course. So let me rewrite this equation in here. So VC is equal to minus W or omega CT in K direction cross product. So if I want to move from D to C, first I must go in the negative J direction, so negative 0.25 J, then negative 0.433 with the negative phi dash. Okay, now we'll do cross product. So negative with negative positive, K cross product J, this is negative, so negative 0.7 or 25, sorry, omega CD in the I direction. Now negative with negative positive, K cross product I, it is positive J, so positive 0.433 omega CD J dash. I will name this equation as equation 2. Now substitute 1 and 2. Okay, substitute 1 and 2. So we have 3J plus in equation 1. Here is the equation 1. 3J plus VCA in the I direction. So write it down in here. So 3J plus VC with respect to A in the I direction is equal to minus 0.25 omega CD in I direction plus 0.433 omega CD Okay, now we have two equations with two unknowns. So let me start with the I equation. So from I equation, on the left side we have only VCA, and on the right side we have minus 0.25 omega CD. Okay, so let me move to J equation. Or do you know what? Let me start with the J equation, then I'll go back to the I equation. Because there is no space and I don't want to move between sheets. So J direction, on the left side we have 3, and on the right side we have 0.433 omega CD, and omega CD is equal to, so 3 divided 0.433, so we are talking about 6.93, and it's positive quantity, so our assumption is good. God bless it, 6.93. Now, if I move to, so let me write it on top. Okay. Actually, it's written in the slides that the omega CD, let me go back to the slide. So, omega CD, we could find the first unknown, and it is 6.93. So, this is omega CD. I will write another 6.93. Now, the other unknown is VCA. So going to the other equation, equation I. So we have VCA, and on the other side we have minus 0.25 multiplied by 6.93 instead of writing VCA, and this is equal minus, as we expect, it's minus sign, minus 1.7. Okay, so we are going to use this quantity, so I will write it. Okay, so VCA, VC with respect to A is equal to minus 1.73 meter per second. Okay, so let's now go to the solving board and start solving for the acceleration in order to find. Now we'll do the same. I'll start from the chord rod A, C, and omega that is given. Okay, and something else. This length is equal to 0.75. Now applying the equation which says that AC is equal to AA plus alpha plus product R C with respect to A minus omega AC squared dot product R C with respect to A, okay, plus 2 omega CA cross product V C with respect to A plus acceleration AC with respect to A. Now the only term that will become 0 is the acceleration. So acceleration will go to 0 because it's flexible. Now acceleration AC is unknown, so I will write it as is, and this is equal. Alpha for this length is given, which is 2 in the counterclockwise, so positive 2 dk direction plus product. This is very simple, which is 0.75 in the positive I direction minus omega squared. Omega is given again, which is 4, so 4 squared is 16 without direction. Okay, dot product 0.75 in the I direction. Okay. Plus 2 multiplied by omega, which is 4k, 4k positive, cross product VCA. We could find it in the previous part, which was minus 1.73 in the I direction. Okay, plus, so this cross product, remember, plus I will assume that this component is positive, so I will write it here, plus AC with respect to A in the positive I direction. Okay, so this is equal K cross product I K cross product I, this is J, so 2 multiplied by 0.75, this is 1.5 J. Okay, now 0.75 multiplied by 16, this is 12, so here we have minus 12 in the I direction. Okay, now K cross product I, this is J positive, and we have minus, so minus 2 multiplied by 4 multiplied by 1.73, this is 13.84, okay, in the J direction, plus AC with respect to A in the I direction. So just rearrange the information. So we have two quantity in J direction, so 13.84 minus 1.5, and this is minus 12.34 in the J direction, minus 12 in the I direction, plus AC with respect to A again in the I direction. So I will name this equation as equation 3. Okay. Now let me move to the other uh, link, which is link DC, and I will use this one. So in link DC, again we'll do the same. So this is D, and here is C being connected, and this distance is 0.5. Okay, if we want to use or to benefit from the inclined coordinate system we find earlier, that this length is equal to point, I think it was 0.25. Okay. So this is 0.25, and this length is equal to 0.4. Let me assure that these values are correct. Yes, 0.25 and 0.4. Okay. So now to write the acceleration equation, we'll get it from relations given in section 16.7. So AC is equal to AD plus alpha cross product RC with respect to D minus omega CD course alpha CD omega squared RC with respect to D. AD is equal to 0 and AC is equal to, so alpha CD, we assume that this length is rotate with this angular velocity clockwise, so it will be minus alpha CD in K direction cross product. If I want to move from D to C, I will move first in minus 0.25 J direction, then I move in negative 0.433 Y direction. Okay, minus omega CD, we could find it in the previous section, and it was positive equal to 6.93, but it is clockwise, so I will write minus 6.93 in the K direction, plus product, or sorry, this is squared, I forget. So we write minus from the statement. Omega CD, this is 6.93 squared, okay, dot product minus 2.5 J direction minus 4.33 I direction. Okay, let us make it simple. So we'll start with minus alpha CD, okay, cross product. So K cross product J, this is negative I, we have three negatives, so we end up with negative 0.25 alpha CD. Now, so this is minus 0.25 in the I direction. Okay, now the other term we have I, so K cross product I, this is positive, and we have two negatives, so it is positive 0.433 alpha CD in the J direction. Okay, now the other terms we have two minuses, so it will be positive 6.93 squared multiplied by 0.25. This is 12 exactly, so 12 in the J direction. And then we have 6.93 squared multiplied by 0.433, and we have no negative, so this is positive, so 20, so positive 20. I will make certain approximation, 0.8 in the I direction. Okay, so this is AC. Okay, Now this is, I'll name this equation as equation 4, and now I will say that equation 3, this equation would equal equation 4. Okay, so we have negative 12.43, negative 12 plus AC with respect to it. Okay, okay, so it seems that we have no space here, so I'll move to new page. Okay, so substitute or equate equation 3 with equation 4. Okay, equate equation 3 with equation 4, or substitute 3 in 4 instead of AC. We'll end up with, now the equation 3 says that AC, acceleration c with respect to d in I direction, minus 12 in I direction, minus 12.36 in j direction is equal to 20.7 or 0.8. Okay, in I direction, and we have minus 0.25 alpha CD in direction. Okay, and we have plus 12 J plus 0.433 alpha CD in J direction. So we have two equations with two unknowns. So let me start with the, what do you think, which one is better? Let us start with the J equation, because I'm caring only about alpha. So if you would like, you can find A, C, D. Okay, so using equation or J equation first, so we have minus 12.36 in the left side. This is equal to 12 plus 0.433 alpha CD. And from here, alpha CD, which is negative, okay, so negative 12.36 plus 12 divided by 0.433, and this is equal, so minus 12.36 minus or plus 12 divided by 0.433, so this is equal minus 0.8. There's something wrong here with the minus sign, so I will edit it. So this is 12. So here we have minus 12. So if I transfer this one to the other side, it will be minus. So the correct answer is minus 56.2 rad per second squared. So the minus sign means our assumption is incorrect. Okay, so the direction of alpha is counterclockwise instead of clockwise. Okay, so going back to the slide, so here is the answer, 56.2 rad per second squared. We assume it at the beginning clockwise, okay, but the correct assumption is to be counterclockwise. So that's it for today's lecture. Maybe on Sunday I will upload for you the last lecture on section 19.3, inshallah. Okay, so until then, see you soon, inshallah, and stay safe.